Hashtag keep it 100. Note 5, not an introductory lesson, because supposedly we already know what's up with the unit circle. So here we go. I'm going to go slow, guys. Oh, those are the extras. Let's start off by drawing the unit circle. I'm gonna make it big, take up the whole space. So here's my axis, here's the y-axis, here's the x-axis, and I'm gonna go. You don't have to do the sound effect. Yeah. Oh, or you can. You know. When I was at the university, his name was Dr. Fultz. He was a cool guy. And every time I would present, I still have the same habits that I had back then. Every time I would present, I would do sound effects like, and all that. And then he would be like, "What was that?" And I'd be like, "What was what? Like, what was that sound?" Like, he's a funny guy. He was a funny professor. Do these 3 segments, guys. Try to space them like, you just eye it 30 degrees away from the axis and then 50 degrees away from each other. They don't have to be perfect. I guess if I were really smart, I would just create that long segment, the diameter from one to the other, but I didn't do that. That's fine. All right, here we go. I'm going to go slow. The radius of a unit circle is 1. So I'm going to start here at this corner. I'm going to say that's 1, 0. I guess I should also say this. This is 0 degrees. This is also 0 radians. So there's my first one. The next one, this is 30 degrees. 30 degrees is the same thing as pi over 6 radians. And that coordinate is square root of 3 over 2, comma 1/2. Now, I just want you guys to observe real quick. As I go counterclockwise, here I am in quadrant 1. As I go counterclockwise, look, I start at 1, 0. The x value starts getting smaller, and the y value starts getting bigger. Do you guys notice that? So, see, that was 1, 0. As I go towards at 30 degrees, that's square root over 2 is like 0.866. See, so the x value got smaller, and the y value went from 0 to 1/2. So the y value is getting bigger. It keeps getting bigger until you hit the 45 degrees. At the 45 degrees, the x and the y are the same. Well, x keeps getting smaller and y keeps getting bigger. At the 45 degrees, x and y coordinates have the same magnitude. Yay or nay? And then after I pass the 45 degrees, which one gets smaller, which one gets bigger?
Y gets bigger, X gets smaller.
Yeah, y gets bigger, x gets smaller. I guess it goes. That's a pattern for the whole first quadrant. Until you reach the y-axis, then it's 0, 1, and then as I go like this, now my x is still getting smaller, but now my y is getting smaller. Do you guys see that? Yeah. When you go more negative, that's smaller in math. In physics, I know that that's bigger. All right, so here we go. 45 degrees. If you want to go fast, like if you want to go above me, that's fine. That's fine. 45 degrees, that's the same thing as pi over 4 radians. And that coordinate is square root of 2 over 2, comma square root of 2 over 2. The next one is at 60 degrees. 60 degrees is the same thing as pi over 3 radians. And that coordinate is 1/2, comma square root of 3 over 2. This is 90 degrees, which is the same as pi over 2 radians. And this coordinate is 0, comma 1. Now my x is still decreasing, but now my y is going to be decreasing. So this right here is going to be a negative 1/2, comma square root of 3 over 2. See, square root of 3 over 2 is a number smaller than 1. Oh, by the way, this is 120. Sorry, 120 degrees, 2 pi over 3 radians. The next one is 135 degrees, which is the same thing as 3 pi over 4. And this coordinate is negative square root of 2 over 2, comma square root of 2 over 2. Are we still okay, guys? What's up? Another one? Yeah.
I didn't draw enough lines.
There you go. $150 degrees, same thing as 5 pi over 6. This coordinate is negative square root of 3 over 2, comma positive 1/2. At 180 degrees, this is pi radians. That coordinate is -1, 0. Are we still okay, guys? This coordinate here, negative square root of 3 over 2, comma negative 1/2. They're both negative. This is 7 pi over 6, which is the same thing as 210 degrees. I guess I should have put the degree first and then to continue with my pattern. Oh well, sorry guys. Next one is negative square root of 2 over 2, comma negative square root of 2 over 2. And let's see, what is this? 225 degrees, which is the same thing as, not everyone at the same time, 5 pi over 4. No, the denominator is 3, so it's going to be the next one, right? Negative 1/2, comma negative square root of 3 over 2. And this is 240 degrees, which is the same thing as 4 pi over 3. Are we still okay, guys? All right. This one right here, that is 270 degrees, which is the same thing as 3 pi over 2. And that coordinate is, you okay, miss? 0, -1. And you scared me. This guy here is 300 degrees. That's the same thing. The denominator is a 3, so the top one is a 5. 5 pi over 3. This coordinate, the x is positive 1/2. Now the x is going to start to increase. And negative square root of 3 over 2. Actually, the x and y both, well, they're both increasing, technically. This one here, the x value is square root of 2 over 2. The y value is negative square root of 2 over 2. That is 315 degrees, which is the same thing as 7 pi over 4. Good job. 330 degrees, which is the same thing as 11 pi over 6. This coordinate is square root of 3 over 2, comma negative 1/2. And then finally, once you've done a full revolution, that's 360 degrees, which is the same thing as 2 pi radians. And then look at what you just did. Look at all that work. Teach your parents about the unit circle, or your guardians, or whoever you live with. They want to know. Are we okay? All right, here we go, guys. Well, I'll wait. Did everything make sense? We haven't done anything. We're just kind of, this is not an introductory lesson. That would be the whatever notes was when we first did unit circle. This is Thomas. Yes, I do. Hey, Esquivel, they called you. Did you know?
Yeah, I told you.
Oh yeah, I thought that was for tomorrow. Oh, okay. Later. Have fun. Because we're going to still be here. Not that this is not fun, but okay. What? I'm not talking smack. Man, Uncle says one of these. Guys, this is a safe space, so it's no violence in here. All right. Analyzing exact versus approximate. Here we go. When I tell you cosine of 30 degrees, you guys will tell me square root of 3 over 2. That's exact. Cosine of 30 degrees, if I just say 0.866, this is approximate. So maybe I should put the little curly signs, which for approximate symbol. This is approximate. Well, this value here. Chav, what do you mean? Okay, so let me take out a calculator. It's okay if you don't have your calculators, guys. We don't need a calculator today. So check it out. I think I already have my calculator in degree mode because I was messing with it last time. Yeah, I do. So check out. So look, check it out. So I'm going to put cosine of 30. I'm going to push enter. And I get that value, see? Square root of 3 over 2 is that value. Look, square root of 3 over 2 And it is that value. Check it out, digit per digit. Now, as soon as you cut it off right here at 0.866, I mean, look, you're rounding it because this goes on forever and ever and ever. Does that make sense, guys? Okay. By the way, if you would have said equals, that's fine. It's not a big deal. But just know that you're approximating because it goes on forever and ever and ever. That's all we wanted to say about that. Go to the next page. Or I guess turn that page around. Just a one pager. We're almost done. See? Don't freak out when you see inverses. What does it mean? Okay. When you see this, so let's start with the cosine because that's what we just started messing with. When you see cosine to the -1 like that, it's not reciprocal. It means inverse. And I'm going to go ahead and write square root of 3 over 2. So what this means, the way you say that, you say it two ways. You say either inverse cosine. That's what that is. Or you say it arc cosine. And what does it mean? Well, it means this. Let's say this equals that to x. And I'll slow down. I haven't done anything yet. All this means is cosine of x equals square root of 3 over 2. And I know that we haven't talked about inverses yet formally. There's something called the principal branch. Okay, I'll slow down. There is infinite many angles that equal square root of 3 over 2, because there is. Every time you do one revolution, once you're at 30 degrees and you keep going, it's always going to. So cosine of 390 is also 30 degrees. How do I know which one? You use the first one. You always start on the positive x-axis. Remember that cosine is the x value, right? And then I keep going and until I hit the first square root of 3 over 2 for cosine. There it is. What's that angle? 30 degrees. You could also say pi over 6 radians. Does that make sense? So on this one, you would say x equals 30 degrees if you're in degree mode. Or you would say x equals pi over 6 if you're in radian mode. That's all it means. And, how do I know which one to pick? What about 11 pi over 6? Because 11 pi over 6 cosine is also square root of 3 over 2. Well, there it is. These are the answers because we're talking about our principal branch. And you'll see what we're talking about when we start talking about inverses. So that just means the very first answer, right? Like the very first one as you go counterclockwise, square root of 3 over 2, there it is. So I'm talking about that, the very first one you hit. So if I take my calculator, check it out, and you guys aren't freaking out. If I go arc cosine, see, look, there it is, arc cosine or inverse cosine, and I write square root of 3 over 2, well, you already know what the answer is. What do you think the calculator is going to tell me? Yeah, look, what did we say it was? It's right. So it's in degree mode, so it's going to give me 30. Yeah, I think I heard someone say it. Look, if I push enter, look, 30. Are you shocked? No, you're not shocked. Is this making sense, guys? Okay. So anytime you see that little -1, what does it stand for? The inverse. How do you pronounce it? Inverse cosine or arc cosine. You hear me say both interchangeably. They're the same. Don't freak out. All right. So let me do one more. So if you see secant with a little -1, you're going to say arc or inverse secant. It's not the same as reciprocal. And I'm going to go ahead and put 2. So what does that mean? What does that mean? This means secant of what angle? Oh, x. Bless you. Equals 2. That's what it means. Now, secant's the reciprocal of which one? See how everything's connected? Secant's the reciprocal of? Do you guys remember? Cosine. Secant theta equals 1 over cosine. That's what it means to be reciprocal. So cosine theta equals 1 over secant. So that means that cosine of x, let me rewrite it. Cosine of x equals 1/2. So tell me, where is cosine x equal to 1/2? Look at quadrant 1, and look, you're looking for the x value at 60. I didn't put a little thing. So there it is, at 60 degrees. So if you have this question here, you would say x equals 60 degrees if you're in degree mode, or if you're in radian mode, you would say pi over 3. Is that making sense to you guys? Nothing crazy, right? Okay. All right. Having radicals in the denominator. Okay, guys. So here we go. I'm just going to make one up. I'm just going to go 1 over square root of 2. This is actually a perfect one. This is a perfectly acceptable answer. This is the same thing as, look, it says rationalize the denominator, rationalize the fraction. So this is the same thing as saying square root of 2 over 2. Chop, how? I want to know. Well, if I were to multiply this by square root of 2 over square root of 2, make sure you multiply by 1. Look, you get 1 times square root of 2, that's square root of 2. And square root of 2 times square root of 2, that's 2, which is this answer here. They're the same value, guys. I want you to make sure. Look, they're the same value. 1 divided, look, I'm going to give it to you guys in decimal. 1 divided by square root of 2, look, 0.707. Check it out. Square root of 2 over 2. Square root of 2 over 2. 0.707. So they're the same. Are we clear? All right. So what else is the same? Well, if I have 1 over square root of 3, that's the same thing as saying square root of 3 over 3. See? So rationalizing the denominator, guys, just means no radicals in denominator. There it is. That's all it means. So if you have something, I'm just making something up, guys. As a matter of fact, let me make up something that's kind of an algebraic question. So let's say I have this, 2 over square root of 2. I'm going to multiply this by square root of 2 over square root of 2. And look what happens. 2 times square root of 2 is 2 square root of 2. And then square root of 2 times square root of 2, that's 2. And look, the 2's cancel out. So there it is. So this is just square root of 2. So this number, 2 over square root of 2, is the same thing as square root of 2. And if I take my calculator and I go 2 divided by square root of 2, look, guys, 2 divided by square root of 2. Don't worry, we're almost done. That is that. And then check it out. If I just type in square root of 2, voila, same thing, digit per digit. Cool or not cool? Yeah, no, like, wow. All right. That's it. We're done. So do you guys have, relax. Take out this. This is called a circuit. So a long time ago, I polled, for a while, I kept doing surveys. And for whatever reason, you guys don't like scavenger hunts when they're in the hallways. I don't know. I would have thought that you guys would have loved that because you get to stand up. But because, sitting down for an hour and a half, that's kind of boring sometimes. But supposedly, you guys don't like that. So this it's like a scavenger hunt, but you don't have to get up. It's on paper. So let's read it. And don't worry, we're going to do the first 3, maybe even the first 4. Maybe even the first 5. We'll see. Beginning in cell 1, use your unit circle to either evaluate or solve. Sketch a portion of the unit circle that helps answer the question. Circle your answer and hunt for your answer to advance in the circuit. Mark the next cell, number 2, and proceed in this manner until you complete the circuit. Okay. First and foremost, these are meant to be done as a group. Do not try to do it by yourself. I mean, you can if you want, but they're meant for you to talk the math life talk with your group. Does that make sense? All right, so here it is. It says that I just go down and look for my answer, for my answer. It starts right here, number 1. It says, evaluate sine 60 degrees. Look at your unit circle. Sine 60 degrees. Here's 60 degrees. Here's 60 degrees. Sine 60 degrees is square root of 3 over 2. So I come back over here, and I'm going to go, this is square root of 3 over 2. I'm going to look for square root of 3 over 2, and I'm going to call it number 2. So let's look for square root of 3 over 2. I see it right there. And I'm going to call that number 2. Do you see what I did? Yeah, because this was number 1. Don't worry, I'm going to do the first 3 or 4. So here we go. It says evaluate cosine of 180 degrees. Cosine of 180 degrees. And I guess I could have just put the equal sign up there, but that's fine. Cosine of 180. I go to my unit circle. So no calculators, you can just reference your notes. You can also take out the printed unit circle if you want to. And at 180 degrees, what is cosine? Did it cosine or sine? I already forgot. Cosine. What is cosine of 180 degrees? -1. So I come back and I go, guys, I think it's -1. You talk to your partners, like, yeah, because cosine is the x. And they're like, all right, perfect. We're all in agreement. And you put -1. Now look for a -1, and we're going to call that number 3. Where's -1? Right there. Number 3. It says evaluate sine 225. Well, sine is the y value. I'm gonna write it again because I like writing it. Sine of 225. Make sure to put a little degree symbol. Sine is the y value. So I look, so here we go. I look for 225. It's right here. And the y value is negative square root of 2 over 2. So there we go. I'm going to go negative square root of 2 over 2. I look for that answer. Where are you? Right there. What do I call this? Number 4. Do you want me to do that one, or do you guys think you guys can take it? Okay, all right. Let's go ahead. Let's work on it, guys. Work on it together. And that's it. That's all. After we're done with that, we're done. Secant is for the reciprocal of cosine. Just remember the letters, they toggle. One starts with an S, so the other one has to start with a C. One starts with a C, the other one has to start with an S. So cosecant, the reciprocal of that is a sine. So it's the reciprocal of sine. You know what I mean? Yes. Yeah. And then let me know if you guys run into issues. Like math issues, not like everyday issues. Yeah.